Hello everyone, this side Manisha Mishra, Assistant Professor in Mathematics in Applied Science Department at St. Andrews Institute of Technology and Management, Gurgaon. And this college is affiliated to Maths Danan University, Rohtak. So guys, today our topic will be evaluation of definite integral involving sine and cosine, right? So this is your fourth unit topic, and this topic is very important because there will be a 7.5 or can be 7.5 marks or can be 15 marks question will come in your final semester exam. And last year there was a question in asked in your final semester exam. So guys, just prepare this topic because one question definitely will be asked, right? So as I told you about Cauchy residue theorem, so we will solve our integral by applying Cauchy residue theorem. But there is a line here, sine and cosine. That means our integral always in form of sine and cos form is given, right? So we have to convert our sine and cosine form into our z forms because we had study our Cauchy's theorem, Cauchy residue theorem in z form, right? So just look at the evaluation of definite integral, right? So just start it now. Definition is, there is a definition by contour integration. That means we will solve our integral by contour integration, right? So for finding the integrals, we take a closed curve. Yes, definitely we need a closed curve to find our integrals. Yeah, this I already told you. Now find first method. So first is find the poles of the function fz, right? Calculate residue at these poles only which lie inside the circle, right? So in Cauchy residue theorem, what we will do, yeah, what we do that first put denominator is equal to 0, right? That we are our poles. Now after finding the poles, what we will check, we will check that that poles are lying inside the circle or not, right? So that poles if lie inside the circle, then we find the residue. So residue means by Cauchy residue theorem. So what is Cauchy residue theorem? Integration fz dz is equal to 2 pi I into sum of the residue of fz at the poles within C, right? So this is your second step. Now we call the curve a contour, and the process of integration along a contour is called contour integration. So this is the process of evaluate to definite integral. That means definite integral, there are two type of integral: definite integral, indefinite integral. Definite integral, that means limits are given and we will get a definite value there, right? Indefinite means limits are not given. That means the answer will be incomplete, right? So just look at here, we have to solve the integral of this type. That means this there will be a question related to this topic further. So we need to solve this integral, right? So integration round unit circle of the type 0 to 2 pi f cos theta sine theta d theta. So there will be an integral of this type is given, and f cos theta sine theta is a rational function of cos theta and sine theta, right? So what is the procedure to evaluate this integral? So just uh, focus here that step 1, convert sine z cos z into a z function. So I told you sine z formula, cos z, sine theta theta formula, cos theta formula in terms of theta, and we will convert it into a z function. So sine theta, I told you, e to the power I theta minus e to the power minus I theta upon 2i. Cos theta, e to the power I theta plus e to the power minus I theta upon 2. We know that. Now As we know also, z is equal to r e to the power I theta. This is a complex number, and this complex number is in the form of polar form. This is called polar form. Polar form means r theta form. So this is our polar form, and there is a point here. This is a circle of unity. That means radius 1. So you can put here r is equal to 1. Consider a circle of unit radius with center at origin as contour, and that means r is given 1. So we have z is equal to e to the power I theta. This is your circle. This angle is theta. Radius is 1. Z is equal to e to the power I theta. So now z is equal to e to the power I theta. Next, we need to calculate our d theta. So d theta, that means you will differentiate z with respect to theta. So dz is equal to a to the power I theta into I into d theta. So we need to calculate d theta from here. So just calculate dz upon iz. That means you will always put d theta is equal to dz upon iz. Now sine theta we have, cos theta. So just you can write a to the power I theta as z, e to the power minus I theta as 1 upon z, because e to the power minus I theta you can write 1 upon e to the power I theta and 1 upon z. So this is your sine theta formula. This is your cos theta. Now put all these values in your equation 1. And what is equation 1? This is your equation 1. This one is your equation 1. This one is your equation 1. So just write all these values here. Then you will get integrand in the terms of z. Then you will calculate your poles and find residue at these poles and will apply Cauchy residue theorem. So there is an example here, and you will better understood by this example. So this question, and further I will discuss 2 or 3 questions more. So these types of question always be asked, and I think this one or other one have or had already come in your final semester exam. So just learn how we will solve this integral. So integration 0 to pi d theta upon 5 minus 3 cos theta. So we have already known 0 to pi limit is given. That means this is a unit circle. That means r is already given 1. Now convert given integral into z form by putting z cos theta is equal to 1 upon 2 z plus 1 upon z is equal to e to the power I theta plus e to the power minus I theta upon 2. So you will always put cos theta, sin theta, this one. This is your theta term form. This is your z term form. So whatever you want to put, just put there. So 0 to 2 pi d theta upon 5 minus 3 cos theta is equal to 0 to 2 pi d theta upon 5 minus 3 cos theta value is here. So just solve this taking 2 as an LCM. So 2 into 5, 10 minus 3 e to the power I theta minus 3 e to the power minus I theta. Right? Now next step is your 2 into 2. So 2 is in your numerator, and 10 minus 3 to the power I theta minus 3 to the power minus I theta. So put e to the power I theta is equal to z. You guys, you can put z cos theta is equal to directly this one or this one. So after that we will put e to the power I theta is equal to z here. So just to put e to the power I theta is equal to z and did theta value. So C is a circle, unit circle, so mod z is equal to 1. After that, integration C 2 into z dz upon iz, this is the d theta value. 10 minus 3z, that means 10 minus 3z, where is it is coming from? 10 minus 3z e to the power I theta is equal to z minus e to the power minus I theta, that means 1 upon z. Right? So just solve this and you will get your final integral. 2 upon I is a constant, then outside dz upon 10z minus 3z square minus 3. Right? So 2 upon I integration C dz upon minus is common, so just taking minus common outside, 3z square minus 10z plus 3. So this is our z form integral. Right? So it is very easy to calculate our poles, because in theta form we cannot calculate our poles, but now we can calculate our poles. So for the poles, put denominator is equal to 0. So this will be our previous topic, Cauchy residue theorem topic. So just find poles from here. So 3z square minus 10z plus 3 is equal to 0. Then 3 3 9, 9 plus 1 10. So 9 and 1 will be the factor of this quadratic equation. So 3z, z minus 3 minus 1, z minus 3, you can write it. 3z is common, then 3z minus 1 is a factor, z minus 3 is a factor. Then you will get z is equal to 3 and z is equal to 1 upon 3. Right? So these both are the simple pole for pole of order 1. Now, which one lie inside the circle? So z is equal to 3 is greater than the radius 1. So z is equal to 3 does not lie inside the circle, but only z is equal to 1 by 3 will lie inside the circle, because 1 by 3 is less than 1. So we will find residue only at z is equal to 3. So z is equal to residue at z is equal to 3 is equal to, simple pole formula will be applicable here. Limit z tends to 1 upon 3 z minus 1 by 3 into fz. Right? This is our simple pole formula. So limit z tends to 1 by 3 minus 2 upon I z minus 1 upon 3. What is your fz? Fz is your, just find fz from here. So fz means minus 2 upon I into 1 upon 3z square minus 10z plus 3. So just write here minus 2 upon I 3z square minus 10z plus 3. So we have already uh, done the factor of these quadratic equations. So what are the factors of these quadratic equations? 3z minus 1 and z minus 3. 3z minus 1 and z minus 3 are the factors of this quadratic equation. So write factor here. So 3z minus 1, z minus 3. So you can write z minus 1 by 3 as 3z minus 1 upon 3. That will bracket will be cancelled out, and only 1 upon 3 z minus 3 remaining. So just write the limit z tends to 1 by 3 here, then you will get your answer minus I upon 4. Just look at here. Here there is a minus 1, we can write iota square. So iota cancelled out, only one iota is here, 2i. So 2i upon 3 into 1 upon minus 8 by 3. So minus iota upon 4 will be here. Right? Now, z is equal to 3 does not lie inside the circle. That means residue will be 0. So hence by Cauchy residue theorem, 0 to 2 pi d theta upon 5 minus 3 cos theta is equal to 2 pi I sum of residues. So 2 pi I minus I upon 4, there is a 1 residue, another will be 0. So you will get minus I pi by 4 plus 0, that means minus I pi by 4. So just multiply iota square 2 upon 4, that means 1 by 2, and iota square value you can write minus 1. So your final answer is pi upon 2, right? And this is your definite value. So this is the final solution of your definite integral involving sine and cosine. There is another one example here. So guys, just we need to remove our cos theta sine theta from the integral. Then second, you will get your integral in only in z form. After third step, put denominator is equal to 0, then you will get your poles, and which pole lie inside the circle, and then you will calculate your residue at that pole. After that, you will apply Cauchy residue theorem. So there are 3 to 4 steps you need to learn and you need to remember. Now, this example which I had discussed, this is very important example, and another one is also very important because there is some trick there. So just look at your example. This is very important example. So evaluate 0 to 2 pi d theta upon a plus b sine theta, and condition is given if a is greater than mod b, right? That means a is greater than mod b, means if b is negative or positive, then that value will be always greater than less than a, right? So your integral is given I is equal to 0 to 2 pi d theta upon a plus b sine theta. So we need to remove our sine cosine from the integral. So d theta is equal to, we will put this value, and sine theta is equal to this one. So just put all these value here. So 0 to 2 pi d theta upon a plus b sine theta value is this one. So just write this one here. Now d theta upon do 2i d theta upon, just taking LCM, then you will get 2ia plus b e to the power I theta minus b e to the power minus I theta, right? Now put d theta and I to the power I theta value. So d theta is equal to dz upon iz. E to the power I theta you will write z, e to the power minus I theta you will write 1 by z, right? Now just solve this, so z cancelled out, and you will get your final integral, this one. Right now, this is your this integral is in the form of z, but we cannot find the roots of this integral because bz is square plus 2ia z minus b. That the roots will be complicated, right? To find to calculate this quadratic equation, calculation will be lengthy, and we cannot understand what is given, what is not given. So just we are considering that the for now, for the post, put denominator is equal to 0, right? So हमने denominator is equal to 0 रख दिया. That means this is a quadratic equation. So we are considering that this quadratic equation has only two roots, right? And that roots are alpha and beta, right? Name as alpha and beta. We are considering that this quadratic equation, this is a quadratic equation, and this quadratic equation has only two roots, because quadratic equation, that means two root will be here. So two roots which are named alpha and beta, right? Now we need to calculate sum of the roots. So sum of the roots formula is alpha plus beta is equal to coefficient of z upon coefficient of z square. So in the quadratic equation, ax square plus bx plus c is equal to 0. So alpha plus beta is equal to minus b upon a. That means coefficient of z upon coefficient of z square. So here coefficient of z is minus 2ia. So sorry, 2ai upon coefficient of z square is b. So alpha plus beta is equal to minus 2ai upon b. Right? Now multiplication of the roots alpha into beta is equal to coefficient of constant coefficient 1, that means minus b upon the coefficient of z. So b upon b minus b upon b, that will be your minus 1. So just look at one thing, why we are finding this one, because we cannot solve this quadratic equation. So we need to calculate the roots, sum of the roots and multiplication of the roots. And always we will solve these type of question by apply this method, right? We don't need to find the roots of this equation and write z is equal to minus b plus minus square db square. No, don't apply this formula. Just calculate sum of roots and multiplication of the roots if condition is given, and condition is given a is greater than b, mod b. Now alpha plus into beta is equal to minus 1. So these are the roots. So positive positive roots means we are finding definite. So just take mod value here. So mod alpha into beta is equal to minus 1, right? Now mod alpha is less than 1, then mod beta is greater than 1. This value mod alpha into beta is equal to minus 1. That means mod alpha is less than 1, then you will get mod beta is greater than 1, right? दोनों में से कोई ना कोई एक रूट तो ऐसा होगा ना जो 1 से छोटा होगा, right? और एक ऐसा होगा जो 1 से बड़ा होगा. Here both of the roots cannot be greater than 1 because there is a negative sign here. इसका मतलब क्या हुआ? That means 1 will be less than 1 and 1 will be greater than 1, right? अगर आपके पास अल्फा 2 है, सपोज अल्फा 1 है और बीटा भी 1 आ गया, तो ये जो राइट हैंड साइड है -1, ये तो पॉजिटिव होगा ना. आपके पास दोनों रूट लेस देन 1 भी नहीं हो सकते. alpha is -1, beta is -1, so -1 will be positive sign. That means one of them will be negative. So mod alpha is less than 1, then mod beta is greater than 1. Then, and you can write also, or mod alpha is greater than 1, then mod beta is less than 1. So one of them have negative sign. So we are considering that mod alpha is less than 1, then mod beta is greater than 1. it means one of them will lie inside the circle, unit circle. So mod alpha is less than 1, that means alpha will lie inside the circle mod z is equal to 1. जो छोटा होगा वही हमारा उस 1 के अंदर लाई कर जाएगा, तो अल्फा यहाँ पर छोटा है, that means alpha will lie inside the circle, beta does not lie inside the circle. So for the this one we need to calculate alpha minus beta. So why we are calculating that, look at just here, after that I will tell you. Residue of fz at z is equal to a at z is equal to alpha. So limit z tends to alpha, z minus alpha into 2 upon z minus alpha into z minus beta. That means why it is coming from, it is coming from, we need to calculate our fz, and our fz is 2 upon bz square plus 2iaz minus b, right? So we have already considered that our roots of this quadratic equation is z is equal to alpha and z is equal to beta. So we can write z is equal to alpha as z minus alpha and z is equal to beta as z minus beta. So we are considering that the bz square and plus 2iaz, we can write that z minus alpha into z minus beta. So z minus alpha cancelled out and you will get 2 upon alpha minus beta. So now we need to calculate alpha minus beta value. So alpha minus beta, you can write alpha minus beta whole square is equal to alpha plus beta whole square minus 4 alpha beta. So because we have alpha plus beta and we have alpha into beta, so just put all these value here. So minus 4a square upon b square plus 4, just calculate this one. So 4b square minus a square upon b square, and alpha minus beta is equal to 2 square root of beta is b square minus a square upon b. So this is your alpha minus beta value. Just write here this value and you will get b upon square root of b square minus a square. So minus 1 is common. A square minus b square is equal to b upon square root of I square a square minus b square, and just iota square is outside. So this is your residue at z is equal to alpha, right? By Cauchy residue theorem, 0 to 2 pi 1 upon a plus b sin theta d theta is equal to 1 upon b integration c 2 upon this quadratic equation into dz. So we have already find our value of the integral. So 1 upon b into 2 pi I into b upon I square root of a square minus b square. After solve this, you will get your final answer 2 pi upon square root of a square minus b square. There is a trick here, so just remember this one, and we will always same thing in our same questions, right? If your denominator is like this, then you can consider your roots alpha and beta and find sum of alpha, sum of roots and multiplication of the roots, and the condition is given a is greater than mod b. So you will apply here, that means one root will be greater than one root will be less than 1. So you can consider which one is less than 1, which one is greater than 1 is it's not matter, but condition always remember to consider. There are 3 to 4 questions here. This is your exercise to solve this questions. D theta upon 2 plus cos theta, so write cos theta d theta value and the answer is 2 upon pi 3 root 3. So just solve these questions, and fourth question 0 to pi. So in our next video I will discuss a question of the limit 0 to pi type, right? So but all the 3 questions you will solve and tell your answer with my answer. And if you guys any problem of any of these topics and any of these questions, then ask me, and 0 to pi limit question I will discuss in our next video, right? Thank you.